Hello, welcome back. Today I will teach you how to configure HTTP2 for the embedded Tomcat server in a Spring Boot application. Let's dive in. Let's understand the difference between HTTP 1.1 and HTTP2. Now, if we talk in terms of connection, HTTP 1.1 opens a new connection for each request, whereas HTTP2 uses the same connection for multiple requests, and it is called multiplexing. If we talk in terms of speed, HTTP 1.1 is slower due to sequential request, whereas HTTP2 is faster as multiple requests load in parallel. When we talk about header compression, HTTP 1.1 sends full headers in every request. Sometimes these headers can be redundant, whereas HTTP2 uses HPAC compression to reduce header size. If we talk in terms of performance, HTTP 1.1 higher latency due to multiple round trips, whereas HTTP2 lower latency and better page load speed. If we talk in terms of priority and streaming, in HTTP 1.1 there is no request prioritization, whereas HTTP2 prioritizes requests and also supports server push events. Let's first create the Spring Boot application. Open any browser of your choice and type start or spring.io and press enter. Alright, then I will select Maven as the build tool. I will select Java as the language. I will select Spring Boot version of 3.4.3. At the time of recording this video, the stable version of Spring Boot available to me is 3.4.3, which might change in your case. Select the stable released version. I'm not going to use this snapshot version since they are still under development. Then I gave the group name as com.create.snap.make and artifact ID as HTTP2 and the name as enable HTTP2 embedded Tomcat. And you can give your description here and the package name here. I will select jar for the packing and Java 23. Then I will add the necessary dependencies. First, I will add wave dependency. Then I will add DAppTools for hot reload. Then I will add Lombok and then click generate. Select the location where you want to save this downloaded project. I will save it inside YT walkthrough and I will say save. Okay, now let's navigate to the directory where you store the project. Let's unzip the project. In case of Windows, we can use WinRAR to unzip the project, but in case of Mac, I will double click. Then let me open IntelliJ IDEA Community Edition. Then I will click open. I will navigate to the directory where I have the project. I will go inside the project and I will select pom.xml and click open. Then I will say yes, open as a project and I will trust the project. And there you go. We have the project open in IntelliJ IDEA Community Edition. Now, if you don't know how to install IntelliJ IDEA Community Edition, please check one of my previous tutorials. I will provide a link in the description of this video. First, let me expand the src directory. And here under our base package, I will create another package and I will name it as API and press enter. Then I will create a REST controller class inside this API package. Right click, new Java class. I will name the class as HTTP2 REST controller. I will select class and press enter. Then on the base package, I will right click again and create another package. I will name it as configurations and press enter. I will create a configuration class which will contain all the necessary pins that we will require for this project. Right click, new class, and I will name it as HTTP2 configurations. Press enter. Then I will use a class level annotation called configuration. The configuration annotation tells Spring that this class is the source of bin definitions, and then Spring application context will look up for all the methods annotated with at the rate bin and create a bin out of them. Now let me open the HTTP2 REST controller. Double click. I will use another annotation for this class and it is REST controller. For simplicity, I have created a simple get mapping in our REST controller which will simply return a message from it. Now let's first run the application and then we will check which protocol is used for communication between the client, which in our case will be the web browser, and the Spring Boot server. To run the application, from the top menu, click on run, then click on run again, then edit configurations, click on the plus icon and select Maven. Then here type Spring Boot run, then click on apply and click on run. And there you go. We have started the Spring Boot application on port 8080 and currently it uses HTTP protocol. And then open any browser of your choice and type localhost 8080/greetings. And then you are getting the response from the Spring Boot server. Now let's see which protocol is used for communication. For that, right click, inspect, then go on the network tab and refresh the page again. If you don't see the protocol here, you can right click on the header and select protocol. And there you go. It is using HTTP 1.1 for communication. Now we will upgrade the Spring Boot server and then it will start using HTTP2. At present, most of the modern browsers don't support HTTP2 over TCP. However, HTTP2 over TLS is supported by most of the modern browsers. To use HTTP2 over TLS, we will first enable SSL in our Spring Boot application. To enable HTTPS in Spring Boot server, we will need an SSL certificate. For development purpose, we will generate a self-signed certificate using Java's key tool utility. First, let me open terminal. I will go to view on the top menu, then I will select tools window, then I will select terminal. Then I will use Java's key tool to generate the self-signed certificate. First, let me create the certificate and then I will explain you what this command does. Press enter. We will use a password. I will say welcome, re-enter password, welcome. I will give the name as break, make, enter. Then organization is developer. What is the name of the organization is NA. What is the name of the city is Dimapur. State is Nagaland. And 2-letter country code is IN. Press enter. I will say yes. And there you go. If you see on the project explorer, you can see the self-signed certificate created here. Now let's understand what is command actually does. Java's key tool GenKeyPair generates a public-private key pair. Think of it as creating a digital ID card for your website. Then it wraps the public key into a self-signed certificate. Finally, the key pair and the certificate are stored in a key store entry identified by the specified alias. Now, alias is like giving your ID card a name so that you can easily refer to it later. If you don't specify the key store option, the default key store file is stored in .keystore in the user's home directory. But here we are telling the command to store the generated self-signed certificate in the project directory. Here, RSA is the encryption method. Think of it like choosing a high security lock for your vault. Key size 2048 sets the strength of the encryption. Now, this certificate will remain valid only for 30 days. And finally, store type PKCS12. Now, there are two ways to enable HTTP2 for the embedded Tomcat server. First, via application.properties or application.yaml. And the second way is by configuration bean way. I will show you both the ways. Now, let's open resources. Click on application.properties. I've already placed the properties that are required. Let me explain what it does. The first property tells Spring Boot to enable SSL. The second property specifies the location of the self-signed certificate. Now, remember, in case of production, you will not be using self-signed certificate. Instead, you will use a certificate which will be signed by a certificate authority. Now, since I said it should be under class path, let me drag this certificate inside the resources folder. In case of Spring Boot, anything which is placed under resources folder will automatically be added into class path, and then we can easily read the file. Now, next is the key store password that we gave while creating the self-signed certificate. Now, this property specifies the alias that we used when creating the self-signed certificate. And finally, this property will specify the store type. And after we have enabled SSL with a single liner property, we can enable HTTP2. Let's check that in action. Let me restart my server. On the top right corner, click on the green button again to rerun the application. Stop and rerun. Now, my application has started on port 8080, and now the protocol changed to HTTPS. Now, let me open the browser again. Our previous version of the application was using HTTP1.1. Let me refresh the page again. Now, you will get an error. Why? Because we have to specify HTTPS and press enter. Now, self-signed certificates are blocked by browser by default. We have to accept the certificate. Click on advanced and proceed. Now, if you check the protocol, it changed to HTTP2. The second way to enable HTTP2 for an embedded Tomcat is by using a configuration bin. Now, don't worry about the speed at which I will explain the class. Try to understand the concept. I will provide the complete code in the description of this video. Let me open the configuration class that we created previously. Here, I have created a bin that provides an implementation of web server factory customizer. Whenever we need to configure the embedded servlet container programmatically, we can register a Spring Bean that implements web server factory customizer interface. The web server factory customizer is an interface in Spring that allows developer to customize the configuration of the embedded web servers before it starts. Web server factory customizer does that by providing access to the configurable web server factory. The configurable web server factory in turn contains numerous setter methods to help us with the customization. The subclass of the configurable web server factory that we are interested in is Tomcat Servlet Web Server Factory, which will allow us to customize the Tomcat Servlet container. Here, I will first create an instance of SSL. Then I will set the key store, the password, the store type, and the alias. Now, these values I could have hard-coded here. Instead, I read them from the application.properties using @value annotation. And finally, I am setting this SSL to Tomcat Servlet Web Server Factory, which will in turn enable SSL. And then, with the help of connector customizers, I am upgrading the protocol to HTTP2. Well, this is all you need to do to enable SSL plus upgrade the protocol to HTTP2. Now, if I can show you the application.properties, I have removed the enable SSL from here as well as the property to enable HTTP2. And these are the custom properties that we created and reading in the configuration class. Let me run the application again and hit the endpoint that we created and check the protocol on the web browser. Let me restart the application. The application got started on 8080 port and it is using HTTPS. Let me hit the endpoint with HTTPS, press enter, and there you go. We have enabled HTTP2 using configuration bin. And there you have it, folks. With very little configuration, we have enabled HTTP2 for an embedded Tomcat servlet container in a Spring Boot application. Remember, for production environment, always use a certificate from a trusted certificate authority. Now, if you found this tutorial helpful, click on the like button, subscribe for more content. Thanks for watching.